P3, the first variant of June 2021. Let's try to do the whole paper in one shot. The first question is about modulus inequality. There is a modulus on both sides. Easiest method, square both sides. Therefore, 2 bracket 3x minus 1, the whole thing square is lesser than x plus 1, the whole thing square. Now you actually have to square it like a plus b whole square. So therefore this is 4 and this is 9x square minus 6x plus 1 lesser than x square plus 2x plus 1. Transfer everything on the left hand side of the equation. So this is 36x square minus 24x plus 4. Of course, first multiply it with the 4 and x square plus 2x plus 1. So 36 minus 1 is 35x square minus 24 minus 2 is minus 26x and 4 minus 1, that is plus 3, is lesser than 0. So you get a 3-term quadratic equation like this. Now, if you can think of factors, that's perfectly fine. Otherwise, you can find the factors using the quadratic equation. Now, let me first think. This is 35 multiplied by 3, that is 105. So 105 can be written as 25 multiplied by something, or it could be something else. So let me first find the factors. So 105 divided by maybe 5, that is 21. So that makes sense. 35x square minus 5x minus 21x plus 3 is less than 0. 5x common, 7x minus 1, and from here minus 3 common, 7x minus 1 is less than 0. 7x minus 1, 5x minus 3 is less than 0. Whenever you have to solve a quadratic inequality, drawing a sketch is a must. So just draw a normal quadratic sketch like this and then label the roots. So 1 over 7 is smaller and 3 over 5 is bigger. So therefore your answer is, it says lesser. That means the region below the x-axis. It's one single region, one single answer. Therefore, x lies between 1 over 7 and 3 over 5. That is the final answer for this part. So write it like this. Every time you do a question, make sure explain it, convey it, communicate it to the examiner in clear-cut terms. Question number 2. What is this about? It says find the real root of the equation. Give your answer correct to 3dp. Your working should clearly show that the equation has only one real root. So this is like an exponential equation. So therefore this is 2 e raised to power of x plus 1 over e raised to power of x, that's the numerator, divided by 2 plus e raised to power of x, that's the denominator, equals to 3. So now let me make a substitution. Let u equals to e raised to power of x. 2u plus 1 over u divided by 2 plus u equals to 3. Let me simplify the numerator first. That's 2u square plus 1 over u divided by 2 plus u, that is multiplication by 1 over 2 plus u, equals to 3. Now cross multiply. 2u square plus 1, that is u bracket 2 plus u multiplied by 3. This is 3 into 2 into u, that is 6u, and u into 3, that is 3u square, and this is 2u square plus 1. So 0 equals to 3 minus 2, that is u square, plus 6u minus 1 equals to 0. So you get this quadratic equation, u square plus 6u minus 1 equals to 0. Now it does not seem that it will have any factors, so use quadratic formula. So therefore u is equals to minus b plus minus b square minus 4 into 1 into negative 1. Is that so? Yes. Divided by 2 times a, that's 2 times 1. So therefore this is negative 6 plus minus 36 plus 4, that is 40. Square root of 40 divided by 2. Now do it separately in this corner. That is root of 40. That is 4 into 10. That's a square root. That is 2 root 10. So leave the answer in this form. So therefore this is minus 6 plus minus 2 root 10 divided by 2. It says your working should clearly show that this equation has only one real root. And what is the logic? So first of all, one of the root is minus 6 plus 2 root 10 divided by 2. The second root is a minus 6 minus 2 root 10 divided by 2. The first one simplifies to minus 3 plus root 10 after division by 2. This is minus 3 minus root 10. But these are the values of u. These are the values of u. And what are we solving for? We are solving for e raised to power of x. So therefore now proceed. But u is equals to e raised to power of x. E raised to power of x is minus 3 plus the square root. And e raised to power of x is minus 3 minus the square root. Take ln of both sides. Ln e raised to power of x is ln of this negative number which is not applicable. It has no solution. So therefore ln of e raised to power of x, that is root 10 minus 3, which is a positive value. Therefore ln of this thing, so let me write ln on this side, a bracket and an ln. So therefore x is equals to ln of this particular value, and which will be some answer. They're asking the answer for how many decimal places? 3 decimal places. So after using a calculator, you get negative 1.818 because ln of this number itself is lesser than 0. That is why ln is coming out to be negative. So this second question is done. Question number 3. This looks like a trigonometry addition formula question and then an equation. So basically it's the concept of an identity, trigonometric identity, that is trig. This is usage of ID and it's about an equation. So first of all, cosine x minus 30. Let me expand this separately. Cosine x minus 30, cosine x cosine 30 plus sine x sine 30. Remember, if there is a negative sign for cosine, it becomes a plus. Cosine of 30 is root 3 over 2. Sine of 30 is half. Therefore, this simplifies to half common. Cosine x root 3 cosine x. Let me write it like this. Root 3 cosine x plus sine x. That is the first part. Then it says sine x plus 30. Sine bracket x plus 30. Therefore, sine x cosine 30 and then plus cosine x sine of 30. Over here, a plus gives you a plus. Cosine of 30 is again root 3 over 2. Sine of 30 is half. So again take that half common out. And this is root 3 sine x plus cosine x. That is the answer for this thing. So let me just highlight it. This pink one is basically this thing. This blue one is this thing without the 2, just this much. So now open it up. So therefore half bracket root 3 cosine x plus sine x, and this is 2 multiplied with half root 3 sine x plus cosine x. Now remember, P3 is all about simplification. So now this half and this half cancels off. You are left with root 3 cosine x plus sine x. This is 2 root 3 sine x and this is 2 cosine x. We want to make tangent the subject. So sine minus this thing, sine x minus 2 root 3 sine x is equals to 2 cosine x minus root 3 cosine x. Take sine x common out, 1 minus 2 root 3. And this is cosine x common out, 2 minus root 3. Is that so? So now just divide both sides by cosine x, both sides by cosine x. So you have tangent x equals to 2 minus root 3 divided by 1 minus 2 root 3. That is the answer that's given at the top for 4 marks. Now it says solve the equation and this much space is given. So basically this is the same thing as above. In other words, tangent x comes out to be 2 minus root 3 over 1 minus 2 root 3. And now you have to use a calculator. And first of all, tangent is positive in first and third quadrant. That is one thing that you need to write. Range is unchanged. That is 0 to 360, non-inclusive. Tangent of alpha is this particular value, whatever that is. Therefore, alpha, since it's in degrees, it comes out to be, is this negative or positive? 2 minus root 3 is positive, 1 minus 2 root 3 is negative. So wait a minute. Therefore, this is second and fourth quadrant because this value is overall, this is positive. Let me write it like this. This is negative, therefore this comes out to be negative, therefore the second and the fourth quadrant. Got the idea? So now you get this basic angle and your final answer is in the second quadrant, your theta or your x is equals to 180 minus the basic angle, which simplifies to 173.8 degrees. And in the fourth quadrant, your x is 360 minus the basic angle, which comes out to be 353.8 degrees. So this is the working that you get for this particular part. Question number 4. Prove that this thing equals to this. So now 1 minus cosine 2 theta, that is the numerator, divided by 1 plus cosine 2 theta. Now, since we need a tangent, we need a sine at the top and a cosine at the bottom. Got the idea? So now this is 1 minus which format of cosine theta is needed and 1 plus which format of cosine 2 theta is needed. So now this is another trig question and this is about double angle and this is about integration. So double angle with integration. Now remember, cosine 2 theta, that is equals to 2 cos square minus 1 and it's also equals to 1 minus 2 sine square. So at the top, I should use 1 minus 2 sine square. So this is 1 minus 2 sine square theta. So this is 1 minus 2 sine square theta. At the bottom, this is 2 cosine square theta minus 1. This one and this one cancels off, this one and this minus 1 cancels off, the 2 cancels off, the minus cancels off. So basically this is sine square theta over cosine square theta, which comes out to be tan square theta. Pretty simple. Hence find the exact value. So this thing simplifies to tan square theta. So therefore this thing is tangent square theta d theta between the limits pi by 6 and pi by 3. Now first of all, a knowledge box at the corner. What goes in the knowledge box? Tangent of, actually we don't need tangent. So hold for a second. First integrate, then think. Sometimes we try to be over smart, thinking everything is in advance and that might lead to errors. So first thing first, is 1 plus tan square is 6 square theta. That's the first thing that you need. So tan square is 6 square theta minus 1. So this is 6 square theta minus 1. This is just the conversion. And now integrate integral of sec square is tangent theta and this is minus theta between the limits pi by 6 and pi by 3. We should know this. Tangent of pi by 3 is root 3 and tangent of pi by 6 is 1 over root 3 or root 3 over 3. That is the logic for this one. They are asking us the exact value, so it should be in terms of theta and in terms of pi and in terms of surds and so on. So this is tangent of pi by 3 minus pi by 3, minus sign in the middle, tangent of pi by 6 minus pi by 6. Now when we are evaluating it, what goes with what? So first of all, you have to simplify this, that goes together, and these two goes together. So let me write this thing, that is negative pi by 3 plus pi by 6. This is the blue working. So this goes like this. And then tangent of pi by 3 is root 3. Tangent of pi by 6, let me use the rationalized form, which is root 3 over 3. So therefore there is a plus sign. This is root 3 and this is root 3 over 3. So the difference between pi over 3 and pi over 6 is pi over 6 with a negative sign. So this is minus pi over 6 and this is 2/3 of root 3. Is that the answer? The answer is yes. Better to write it like this. First the positive term and then the negative term. This is the exact answer for this integral. Question number 5. What is this question all about? So this question is all about, let me put an orange marker over here, and this thing is about, looks like, complex number. Now first thing is, solve the equation such and such. Z square minus 2pi z minus q equals to 0. Now let me highlight this. This is the variable. This is the variable. Therefore, the coefficient is 1. The coefficient is minus 2pi and the constant term is this thing. So if I compare it with az square plus bz plus c equals to 0 instead of the x, the usual x. So a comes out to be 1, b comes out to be minus 2pi and c comes out to be negative q. I am always interested in b square minus 4ac first because it's a complex number question and this would may be causing any trouble with a square root. Square root minus 2pi, the whole thing square, minus 4 into 1 into minus q. Let's draw this across. So therefore this is 4pi square plus 4q. It goes like this. Then it becomes minus 4p plus 4q. Then it goes like this. Then take 4 common out and this is basically a square missing. So this is q minus p square and there is a square root and this is 2q minus p square. So that is this much for b square minus 4ac after the square root. So this thing, the orange one, this is square root of b square minus 4ac, that is the simplified version. And then when you are solving for z, that is minus b plus minus b square minus 4ac square root divided by 2 times a. So minus, that is a plus 2pi plus minus. This is 2q minus p square, already simplified, divided by 2 times 1. So take 2 common out and divide. What are you left with? You are left with a pi plus minus q minus p square. And there are 2 roots. The root number 1 versus root number 2. Root number 1 is minus q minus p square, that's the real part, plus pi. And the other one is q minus p square plus pi. These are not conjugates. Why they are not conjugates as such? Because one of the coefficient was imaginary. So these are the 2 roots that you get. Now, what does it say? And don't forget the square root. There is a square root at the top because 4 is taken out. There is a square root at the top. 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 Don't forget that. Now, these are the two roots. And what more? In an Argand diagram, now they are relating it with an Argand diagram. In an Argand diagram with origin O, so in an Argand diagram with origin O, the roots of the equation are represented by distinct points A and B. Given that A and B lie on imaginary axes, find a relation between A and B. This could be an equation, this could be an inequality only for 2 marks. Now, if they lie on imaginary axes, what does it mean? It means that the roots are imaginary. So therefore roots are imaginary, that is for sure, and therefore the discriminant is negative. So it's like a quadratic question. So what is the discriminant? The discriminant is 2 square root q minus p square. B square minus 4ac is already evaluated for you. So this is 2 square root and this is q minus p square is less than 0. Q minus p square with a square root is less than 0. Q minus p square is less than 0. Find a relationship between p and q. So q is lesser than p square. That is what you get. Next part. Given instead, so this is just a continuation of that. Given instead that OAB is equilateral triangle. So OAB is equilateral, express Q in terms of P. A small sketch will be very, very useful. So if I draw the sketch over here, this is the origin and there is a root that is over here. How can I say that? Because the x and y are positive. That is root number 2. X is positive, y is positive. Real is positive and this thing is positive. So let me label this thing as A. So this one is A. And somewhere here, let me label this point as B, because this thing is the positive square root and this thing is how much? This is pi. So basically this is pi. And this thing is the negative square root and again this is pi. Now the question is, this is one part, something like this. This is one length. And this is the other length, something like this, and it's not drawn to scale, so don't worry about that. And this is the third line that I'm drawing in green, something like this. If this is an equilateral triangle, that means OA, OB, AB should all be the same. So OA and OB, this should be magnitude of this vector. So that should also equals to AB. So let me first write down what is OA. OA is this value square, q minus p square square root. So this is q minus p square. Let me first write OA as a vector. So this is q minus p square square root and this is p. I'm treating it as a vector. Therefore, OA magnitude, that is q minus p square square root square and p square, and don't forget the square root at the top. So therefore, this is q minus p square and this is p square and there is a square root at the top. So this simplifies to square root of q. Leave the answer as it is. That is OA. What else is there? After you get this thing as OA, can you find out what is AB or BA? So AB, yeah, let me call this thing as BA. That's B to A. That's the same thing as AB. So therefore, this magnitude is the same. Basically, what I am doing is that the magnitude of BA, that is this thing, simple addition, this plus this. That is 2 times square root, and what goes inside the square root, p minus q minus p square. You don't need a square root because I'm not using a formula. I'm simply adding it up. This is just like saying this is minus a, this is plus a, so the difference is 2a. So basically this is like your a. Got the idea? Now you would say 2 square root q minus p square is equals to root q. Square both sides. 4 bracket q minus p square is equals to q. 4q minus q is, first of all, 4q minus 4p square is equals to q. 4q minus q, 3q is equals to 4p square. Therefore, q is equals to 4p square divided by 3. That is the relationship between q and p, and this is q is the subject, q in terms of p. Got the idea? So question 5 is done. So that was a question that came a little bit difficult early on. That was very conceptual. So now let's work on question number 6. What does it say? Parametric equations. So let me label it. Some of these were not labeled initially. So this is parametric equations, and of course differentiation. X is equals to ln 2 plus 3t. dx by dt, 2 plus 3t goes down, 3 goes up. Y is equals to t over 2 plus 3t. U is the numerator. V is the denominator. U prime is 1. V prime is 3. It's a quotient rule. So I'm applying quotient rule. So I'm starting with V. So therefore, dy by dt, that is 2 plus 3t multiplied by 1 minus 3 multiplied by t divided by the denominator squared. So the 3t cancels. This is 2 over 2 plus 3t square. And now join the two. dy by dx, dy by dt divided by dx by dt. So therefore this is 2 over 2 plus 3t, the whole thing squared, divided by dx by dt, which is 3 over 2 plus 3t. Simplify it. That's 2 at the top, bracket square at the bottom, into bracket at the top, 3 at the bottom. So 2 plus 3t, and this is 2 plus 3t whole square. So basically this is 2/3, 1 over 2 plus 3t. This is the simplified version of dy by dx. So highlight this particular thing. That is dy by dx is this much. Now what does it say? Show that the gradient of the curve is always positive. First of all, there are 2 warning signs that should be written underneath. What are those 2 warning signs? Here and here. The first thing is 2 plus 3t should never be equal to 0, because if denominator should not equal to 0, 2 plus 3t should not equal to 0. In other words, t should not equal to minus 2/3. So t should not equal to minus 2/3. Everything else is good. Second thing, ln only exists for positive values. So 2 plus 3t should be greater than 0. T should be greater than minus 2/3. Now t should not be equal to minus 2/3. T should be greater than minus 2/3. Therefore, for this one, t should be greater than minus 2/3. Therefore, for all values in the domain, t is greater than minus 2 over 3. The denominator will always be positive. Therefore, dy by dx will always be positive. Therefore, it will always be an increasing function, but they're not using the terminology of increasing function. They are happy with this. Now, what else is there? Find the equation of the tangent at the point where it intersects the y-axis. Intersects y-axis means x is equal to 0. That is the very, very basic coordinate geometry that always comes. When x is 0, ln 2 plus 3t, let me write it first. X is equals to ln bracket 2 plus 3t. ln bracket 2 plus 3t equals to 0. 2 plus 3t is equals to e raised to power of 0. E raised to power of 0 is 1. So therefore, 3t equals to minus 1, t comes out to be minus 1/3. That's the first thing that you get. dy by dx is 2/3 1 over how much? 2 plus 3t. So that is 2 plus 3t. If t is minus 1/3, so 3 into minus 1/3 is minus 3. Minus 3 plus 2 is minus 1. Therefore, dy by dx is equals to minus 2/3. This is gradient of tangent. Are we interested in tangent or are we interested in normal? They are interested in tangent. So therefore, your gradient is this much. And what else is left? So we have the x coordinate, which is 0. Do we have the y coordinate? No, we don't have the y coordinate. So when t is equals to minus 1/3, y is equals to what? That is t divided by 2 plus 3t. T divided by 2 plus 3t. Therefore, substitute. So therefore, this is minus 1/3 at the top divided by 2 plus minus 3. That is minus 1/3 at the top divided by minus 1, which comes out to be 1/3. So the coordinate is 0, 1/3. And was it positive or negative? It's a negative at the top, a negative at the bottom. So therefore, the y value is positive. Therefore, y minus y1 is equals to mx minus x1, y minus 1/3. And this is equals to m, which is minus 2/3 x minus 0. So therefore, this is y minus 1/3 is minus 2/3 x. Therefore, y is equals to minus 2/3 x plus 1/3. They did not specify any format, so you can write in any format of your choice. Question number 7. This looks like differentiation. And then it's a question of numerical solution of equation. So this is basic differentiation, not very, very basic, plus a normal numerical solution of equations. First of all, what is the question about? It says there is a curve, and again someone is over obsessed with this thing that is called the quotient rule, because in the previous part quotient rule was already asked. Y equals to tangent inverse x divided by root x. Show that A satisfies this equation where the x coordinate of that maximum point is A. U is tangent inverse x. Therefore, u prime, this was something new in the syllabus, 1 over 1 plus x squared. This is simple usage of formula. V is equals to root x. V prime, again kind of a standard integral, 1 over 2 root x. So we are starting with V. So therefore, dy by dx, that is root x over 1 plus x square, and then minus 1 over, so this is tan inverse x at the top divided by 2 root x. This is just the numerator divided by the denominator squared. So write it like this first. Now take LCM. When you take LCM, this is 1 plus x square multiplied with 2 root x, and this 2 root x and root x, that becomes 2x minus 1 plus x square into tangent inverse x, and this becomes x. So now take everything down. This is 2x minus 1 plus x square into tangent inverse x divided by 1 plus x square into 2 root x into x. So far so good. Since it's a maximum point, it's a turning point, so dy by dx is equals to 0 because it's a stationary point. Therefore, numerator 2x minus 1 plus x square tangent inverse x equals to 0. Minus of this bracket, tan inverse x is equals to negative 2x. This negative disappears. Therefore, tan inverse x is equals to 2x over 1 plus x square. Now, since they are talking in terms of a, when x is equals to a, everything is happening. So therefore tangent inverse a is equals to 2a over 1 plus x square, 1 plus a square. So therefore a is tangent of 2a over 1 plus a square. Is that the answer? 2a over 1 plus a square, that's the answer for this part. Verify by calculation that this root lies between such and such. So take everything on one side. It depends on whether you need this particular format or you are interested in this particular format. Everything is good. I think I'll stick with the tangent format because that's a button in the calculator. Of course, you have a tan inverse also. So a minus tangent of 2a over 1 plus a square equals to 0. Let's call this thing as fx. So fx is this thing. This thing is fx. This thing and this thing. So this thing and this thing. So that is fx. Let me write it again. This is a minus tangent of 2a over 1 plus a square. Plug in 1.3. Plug in 1.5. There will be a change of sign which will signify the fact that the root alpha lies between 1.3 and 1.5. Now it says use an iterative formula based on the equation in part 1. So that is the iterative formula. It was already alone, the a. So this thing is the iterative formula, a n plus 1. So let me highlight it. A n plus 1 is equals to tangent of a n over 1 plus a n square, something like this. What should be the starting value? The starting value should be the mid value, which is 1.4. So let's start off with 1.4 and make sure your calculator is in the radian mode. So calculator in radian mode, that is a must. So therefore tangent of 1.4 divided by 1 plus 1.4 square, and then you take out the tangent, work in 4 decimal places. This comes out to be 1.3865. Keep on repeating the thing. This thing is a2. So let me first write like this. And this thing is a2 equals to this. Now a2 is this. And a3 is coming out to be 1.3951. Similarly, a4 is coming out to be 1.3896. And a5 is coming out to be 1.3931. Hold for a second and think. This answer and this answer is not the same, correct to 2 decimal places. This is 1.40. This is 1.39. So therefore proceed. Now when you have this value, round it off to 2 decimal places is 1.39. As long as you get two things the same according to their level of accuracy, therefore the root of this equation is 1.39. That is the answer for this particular part. Let's move on. Vectors. It says with respect to the origin, the points A and B have position vectors such and such. So OA is 1, 2, 1 and OB is 3, 1, minus 2. Let me find AB, which is 1, 2, 1. Actually, it's OB minus OA. So this is 3, 1, minus 2, minus 1, 2, 1. 3 minus 1 is 2, 1 minus 2 is negative 1, and minus 2 minus 1 is negative 3. That means BA will be negative 2, 1 and 3. Double check. This is 3 minus 1 is 2, 1 minus 2 is negative 1, minus 2 minus 1 is negative 3. Why am I choosing this particular format? Because it has lesser negative sign. This is the direction vector of L. So this is direction vector of L. And this is direction vector of line passing through A and B. It says between the directions of AB, so direction of AB dot product with direction vector of line L should give me magnitude square root cosine of theta. Direction vector of AB or BA doesn't make a difference, which is minus 2, 1 and 3. Dot product with 1 minus 2, 1, 1 minus 2, 1 is equals to square root of 14, square root of 6 cosine of theta. And now minus 2, let me highlight it. So this is minus 2 into 1, and then 1 into negative 2, and then 3 into 1. So therefore this is minus 2 plus minus 2 plus 3 divided by root 14 root 6 is equals to cosine of theta. This overall is coming out to be negative 1. So since we are asking for acute angle, remove overall negative sign. So therefore cosine of theta is 1 over root 14 root 6. You use a calculator and you find the answer as acute angle. So therefore that is done. Now the next part. Find the position vector of the point on L such that AP equals to BP. It's not necessarily the midpoint. Keep that in mind. First of all, vector equation is 2 plus lambda, 3 minus 2 lambda, 2 plus lambda, 3 minus 2 lambda, and the next one is 1 plus lambda. This is OP. What is AP? That is OP minus OA. Similarly, what is BP? That is OP minus OB. So think very closely. 2 plus lambda, 3 minus 2 lambda, 1 plus lambda, and this is 2 plus lambda, 3 minus 2 lambda, and this is 1 plus lambda. So let me just shift it a bit on this side, and let me just shift this thing, and let me draw brackets over here. This is like this, minus something, and this is like this, and then minus something. So let me draw a kind of a bar in the middle, something like this, a little bit longer. So now what goes over here? Your OA is this one, that is 1, 2, 1. So this goes here. This is 1, and this is 2, and this is 1. Similarly, what is OB? OB is this, 3, 1, minus 2. So this is 3, 1, minus 2. Now simplify. This is 2 minus 1, that's 1 plus lambda. 3 minus 2 is 1 minus 2 lambda. 1 minus 1 is 0. This is simply lambda. Over here, 2 minus 3 is negative 1 plus lambda. 3 minus 1 is 2 minus 2 lambda. 1 minus minus 2 is 3 plus lambda. Double check once and for all, so that everything is all set. So you have 1 plus lambda. I'm double checking it. 1 plus lambda, 1 minus 2 lambda, and lambda. This is lambda minus 1. Yeah, minus 1 plus lambda can be written both ways. 2 minus 2 lambda and 3 plus lambda. Since they are equal, therefore the modulus are the same. So therefore, when the modulus are the same, simply you have to make a quadratic equation. AP modulus equals to BP modulus, that is 1 plus lambda whole square, and this is 1 minus 2 lambda whole square, and this is lambda whole square. This is minus 1 plus lambda whole square, and this is 2 minus 2 lambda whole square, and this is 3 plus lambda whole square, and you get a quadratic equation. And they are basically asking us for the position vector of such and such. Now you will end up with an answer, and then when you plug in that particular answer, what will you get? I'm going to simply write that value. So therefore, obtain a position vector. Lambda comes out to be 6. Therefore, the position vector of P which is OP, that comes out to be 8 minus 9 and 7. 8 minus 9 and 7. Are they asking us in any particular format? They are asking us the position vector, so this is perfectly right. Question number 9. Equation of a curve is this. It has stationary point, that is differentiation, and then it's about integration. So differentiation is the first part, integration is the next part. So this is question number 9. So I hope there's only one other question left, because this paper is very, very lengthy. I mean, P3 is lengthy. You can't skip it. So y is equals to x raised to power of minus 2/3 ln x for x is greater than 0. The curve has one stationary point. U is x raised to power of minus 2/3 u prime minus 2/3 x. Minus 2/3 minus 1 is minus 5/3. V is ln x and v prime is 1 over x. So now this is a product rule. So therefore dy by dx, that is uv prime x raised to power of minus 2/3 multiplied with 1 over x plus minus 2/3 x raised to power of minus 5/3. Let me write this thing as minus 2/3 into x raised to power of 1. Actually minus 1. And this is this much multiplied by ln x. Double check. Basically, this is what I'm doing. uv prime, vu prime. There is no denominator. Now, can I take something common out? Yes, I can. This one and this one. That's why I took this thing. So therefore, this is x raised to power of minus 2/3. 1 over x is left inside, and this is minus 2/3 1 over x, and this is ln x. I can also take 1 over x common out. So x raised to power of minus 1/3 into 1 over x, and this thing is 1 minus 2/3 ln x. When I equate it to 0, dy by dx equals to 0, x raised to power of minus 1/3 is 0. So therefore, what is the solution? So therefore, there is a solution of 0. 0 raised to power of something is 0. Actually, just reject it, because it says x is positive. Similarly, 1 over x is equals to 0. Again, reject it, because you won't be getting any real solution, something like that. Infinity. 1 minus 2/3 ln x equals to 0. Minus 2/3 ln x is equals to negative 1. 2/3 ln x is equals to positive 1. Ln x is equals to 3 over 2. Therefore, x is e raised to power of 3 over 2. That is the x coordinate. That is perfect. And what do you need now? You need the y coordinate. Y is x raised to power of minus 2/3 ln x. Y is equals to x raised to power of minus 2/3 ln of x. So now when x is e raised to power of 3 over 2, y is e raised to power of 3 over 2, raised to power of minus 1/3. This is one portion, ln of e raised to power of 3 over 2. So this cancels off. This is e raised to power of minus 1. This is 3 over 2 ln of e. Ln of e is 1. This is 3 over 2e. That is the answer. Therefore, write the final answer as the coordinate. E raised to power of 3 over 2, comma 3 over 2e. It's more English than math. That is the working for this one. Now it's asking us to integrate this. And this would be integration by parts. U dv. That's u v minus integral v du. So what do you have? X raised to power of minus 2/3 ln x. X raised to power of minus 2/3 ln x dx. Apply the concept of LATE. This is the order for choosing u. It's all about u. So therefore, u is ln x. dv is x raised to power of minus 1/3 dx. This time you are integrating it. U is differentiation, du is 1 over x dx. The dv part I was talking about, this time you are integrating it. So minus 2/3 plus 1 over minus 2/3 plus 1. That is x raised to power of 1/3, and division by 1/3, that is 3x raised to power of 1/3. Double check it. Now, This is uv, so this is u, this is v, and then this is v du minus v du. So therefore, let me highlight this and let me highlight this. So this is 3x 1/3, or I can even write this thing as cube root of x ln of x minus integral 1 over x is multiplying with 3x raised to power of 1/3 dx. Simplify it further. The integration still there. 1/3 is at the top, 1 is at the bottom. That is 3x raised to power of minus 2/3 dx. 3x power 1/3 ln x minus 3 as it is, x minus 2/3 plus 1 minus 2/3 plus 1. Minus 2/3 plus 1 is 1/3. Division by 1/3 is multiplication by 3. So 3x 1/3 ln x minus 9, and this is again x raised to power of 1/3. So take 3 and x raised to power 1/3 common. This is ln x minus 3. Now everything is set. Now plug in the limits. What are the limits? Limits are 1 and 8, and your answer will be in exact form. So this is 1, this is 8. This is 3 cube root of 8, and this is bracket ln 8 minus 3 minus 3 cube root of 1 and bracket ln of 1 minus 3. So ln of 1 is 0, cube root of 8 is 2, cube root of 1 is 1, and what are you left with? So this is 3 ln 8. This is 3 into 2 is 6. So therefore this is 6 ln 8 minus 6 into 3 is 12. This is ln of 1 is 0. There is a minus, there is a minus. So 3 into 3 is 9, if I'm not mistaken. So therefore minus 12 plus 9 is, I need a 9, 18 ln 2. Okay, that I can adjust it. But before that, let me get things straightened out over here. So I hope everything looks fine. Division by 1/3 is multiplication by 3, and this is positive. So this minus remains. And this thing was 3 cube root x ln x minus 9 cube root of x. That makes perfect sense. You plug in 3. Let me double check. You plug in 3, and 3 is only for this part, and this is 9. So therefore this is 3, this is 3, that is perfect. Cube root of x is taken common out, ln x minus 3, that is also perfect. Cube root of 8 is 2, 3 into 2 is 6, this is 6 ln 8. 6 into 3, okay, got it, that was my mistake. 6 into 3 is not 12, 6 into 3 is 18. So I got that thing corrected. So therefore this is 6 ln 8 minus 9, and now the last part, 6 ln 8 is 18 ln 2. How did they do this? This is 6 ln of 2 cube minus 9. Take this 3, take it down. So that is 18. And this is of ln 2 minus 9. Is that the final answer? Yes, that is the final answer. And that is the working for this one. Question number 10. Now it's diffie-q, differential equation. Variables x and y are related by this equation such and such. Dx by dt is this thing, and that's the condition. So x square goes down, and 1 plus 2x also goes down. So this is x square, 1 plus 2x, and what goes at the top? 1, and this is dx. And nothing is there with dt except 1. Integration, integration. Now over here, this thing divided by this thing. This has to be done using partial fractions. So let's get started. Don't proceed any further until you have done partial fraction. Now, which case of partial fraction is that? First of all, it's a proper fraction. That is the first thing. It's a proper fraction. Can I treat this thing as a quadratic case or as a linear repeated? It's better to treat it as linear repeated. So therefore, when I do the working, both choices are possible as such. But from the perspective of integration, linear repeated is better. Let me write it both ways. I can write this thing as a over 1 plus 2x and bx plus c over x squared. This is treating it as quadratic. Or I can write this thing as a over 1 plus 2x and q over x and r over x squared. So this is linear repeated. So your choice. I think let me go ahead with the quadratic part. So 1 over 1 plus 2x multiplied by x squared, because this is like x squared plus 0. That is a over 1 plus 2x and bx plus c in brackets divided by x squared. Take the LCM. So 1 is equals to a multiplied with x squared and bx plus c is being multiplied with 1 plus 2x. Let x equals to negative half. So bx plus c disappears. 1 is equals to negative half squared, that is 1/4 of a, therefore a comes out to be 4. So a, the numerator of the linear factor, this is coming out to be 4. Now let me proceed. 1 is equals to 4 bracket x squared and this is bx plus c being multiplied with 1 plus 2x. Now let me choose x equals to 0. So therefore 1 is equals to 0, b becomes 0, c remains as it is multiplied by 1. In other words, c comes out to be 1. What is c? C is this constant on top of this bx plus c. So therefore c comes out to be 1. Now substitute it again. 1 is equals to 4x squared plus bx plus 1 multiplied with 1 plus 2x. Choose any value of your choice besides the one that you have chosen. So which ones have you chosen? You have chosen x is equals to minus half. You have chosen x equals to 0. And now you are choosing something else. So let x is equals to 1. Let x equals to 1. Let me write it in black. Let x equals to 1. 1, this is 4 into 1 square. This is b into 1, that is b plus 1, and 1 plus 2 is 3. So 1 minus 4 is negative 3, that is b plus 1 into 3. Negative 1 is b plus 1, therefore b comes out to be negative 2. This thing is also done. Now rewrite it again. A is 4, so that's 4 over 1 plus 2x. So this is 4 over 1 plus 2x. That's the first thing. B comes out to be minus 2 and C comes out to be 1. So this is minus 2x plus 1 divided by x squared. So far so good. And what else is there? And these are the terms that you get for integration. This is 1 and this is dt and something like this. Now, is this in a position that you can integrate? The answer is no. You have to break it up. So break it up. So therefore, this is minus 2x over x squared and this is 1 over x squared dx. Got the idea? So after I break it up, now do I have extra space? I have a lot of extra space. And let me take everything to the other page. 4 over 1 plus 2x. Let me write it like this. Integral 4 over 1 plus 2x. So this is 4 and this is 1 over 1 plus 2x dx. I'm writing this separately. Then I have minus 2x over x squared. So then I have minus 2x over x squared. That is the next thing. And then I have, or let me write it even more. This is minus 2 x over x squared. I'll simplify it first. And the last thing is 1 over x squared, that is x raised to power of minus 2. And this is 1 into dt. So many integration signs are there. Simplify this. This is x1 and this is this. So this is an ln term. This is an ln term. This is basic. This is basic. This is ln. This is ln. Now let me write it everything. 4 as it is. 1 over 2 ln 1 plus 2x. That's the first thing. This is minus 2 as it is. 1 over x is 1 over 1 ln of x. Then x raised to power of minus 2 is x minus 2 plus 1 over minus 2 plus 1. I'll simplify it. And this is t plus a constant of integration c. Do we need to make something the subject? We need to make t the subject of the equation, t in terms of x. So I can either write a c on this side, or let me write a c on this side, and this equals to t. So that it's already the subject. So this is 2 ln 1 plus 2x. This is minus 2 ln x. This is minus 1 over x. Double check it. Yes, it is. Plus c equals to t. So it's already the subject. All you have to do is to evaluate c. What condition is there for us to evaluate c? This is this. X is 1, t is 0. So therefore, plug this thing in. X is 1 when t is 0. So therefore 2 ln 1 plus 2 is 3 minus 2 ln of 1. This will cancel off. Minus 1 over 1 plus c equals to 0. So ln of 1 is 0. This thing disappears. This thing has a minus sign. And 2 ln 3, can I write this thing as ln of 9? So this is ln of 9. And this is minus 0. And this is minus 1. This is plus c equals to 0. So therefore c comes out to be 1 minus ln of 9. So I have written this thing like this. C is 1 minus ln of 9. Now it says obtain a correct expression. So this is almost done. There are two terms, t equals to. So now t equals to, there is 2 ln 1 plus 2x, 2 ln bracket 1 plus 2x, minus 2 ln x, and this is minus 1 over x, and this is 1 minus ln 9. Do we need to simplify it further? Obtaining an expression for t in terms of x, it's already simplified. Unless k, you want to gather the terms together, something like that. So if I make it like this, from these two, take this 2 and this 2 common out. So this is 2 common, ln 1 plus 2x minus ln x, bracket closed, minus 1 over x. And there is also this ln of 9. So write it also like this. First of all, let me write it. ln 9 can be written as ln of 3 square, which is 2 ln 3. So now write it everything like this. So now there is a 2 over here. So take this 2 common out. This 2, the blue one, that's 2 common out. That is minus. So therefore this is ln 1 plus 2x minus ln x. And this is minus ln 3. And this is minus 1 over x plus 1. So therefore this is 2. This is ln 1 plus 2x. And this 3 and x would multiply. That's a 3x. And bracket closed. And therefore this is minus 1 over x plus 1. So I have simplified it a bit further. And that luckily completes May-June 2021 variant 31 paper, and that was an awesome paper to do. Stay tuned for more.